and then I call the function. So in order to get the parent ID, what we have to do, we write here get ppid, and then we call the function, and after that we run a print statement, excuse me. We write here, let me just go to the next line, printf, and then inside these brackets, what I'm gonna do, that I'm gonna write here process ID, and then I'm gonna put here the percentage sign, which is for percentage d is for integer. Then I'm gonna put /n, which means that we want to go to the next line, and /t was for tab, okay, previously that we have used. And then we're gonna put a comma here, and then I'm gonna write here the variable name, which is essentially process ID, okay. And then I'm gonna write here printf, and now I'm gonna write here parent process ID, and again I'm gonna write here percentage d /n, and then obviously the variable name, which is essentially par underscore process then ID, okay. So yeah, that's it. So we save it, and obviously on the output what we would get the process ID, which would be which we would receive using this get PID built-in function, which is inside this header file, and this get ppid, get parent ID, parent process ID function, which is inside this, which is built in inside this header file as well, okay. So we save this, we open up our terminal, so we run this, we write here C program .c -o, and then we write here the binary file tst, and you can see that we have no error in the file. So now I would just run the binary file, we hit enter. So this is the process ID that we have got, and this is the parent process ID, okay. So the process ID is 10944, and the parent process ID is 10871, okay. So there are other complex examples as well that you can take a look into from the book. We'll move to the next topic. Okay, so the next topic that we are going to discuss is memory allocation. All right, so in regards to the memory allocation, so basically the purpose of memory allocation is that you can allocate and release memory whenever it is required, okay. So in this book, the book that we are following, there are basically four main functions in C that have been used, okay, and those are the functions that we are going to use as well. So the name of the functions, I'm just going to write them down here. So the first function is MALLOC, okay. The second function, the first function is MALLOC, which also stands for memory allocation. Let me just name it here as well, memory allocation, okay. So this is a built-in function. The second function that we're going to use is CLLOC, okay, which stands for contiguous allocation, okay. And after that we have the free function, which is basically, remember that this hyphen or minus sign, it's not the part of the function, okay. The function starts here, this hyphen sign is just for, you can say, for numbering or for anything, okay. So free, this is the function that we'd call, it starts from F, okay. So this is for basically deallocating the memory, okay. So if you want to deallocate the memory, then this is the function, okay. And then the last function is the reallocate function, okay. So this function is used to reallocate. All right, so I hope you've got the point. So these are the four functions that we are going to use in the memory allocation. So let's go ahead and let's try to write the code. All right, so what we are going to do is that we are going to use a library which would basically have the functions, okay. So these four functions that we have talked about, so what we are going to do, that we are going to use that header file, which is essentially stdlib.h, and this is the header file that contains all the functions. And then we're gonna have here integer main, and after that we're just gonna clear it. All right, so first of all we are going to create a pointer. In C we always do that while working with the especially with the processes and especially with the memory allocation. Yes, so right here int steric ptr, and then we just put a semicolon to end this thing, and then after that we write here integer, and we need to define two variables, and I'll explain to you later for what purpose we have defined them. So first of all we defined num, let's say, and the second variable that we're going to define, let's call it sum, okay, which is we call it sum, and obviously we're going to perform some sort of addition on it, obviously as the name represents. So we would initialize it so it doesn't have any garbage value. Okay, so in C garbage value is just another concept that we would discuss later in this video maybe, but for now you just remember that whenever you are initializing a variable, initialize it with 0, because sometime maybe previously you have used the same variable and it might have garbage value. Okay, so in that case it could affect your output. Okay, so just it is safe to initialize the variable with 0. Okay, so the next thing that we are going to do is that we are just going to get the number of elements. Okay, so let's say we want to allocate memory for 8 elements. Okay, so when we would like to allocate the memory for 8 elements, then we are just going to give it the size for each block and for each element. Okay, so one block, let's say we give it an integer, we typecast integer and we give it an integer value. Okay, so int num is basically we are going to give it the number of elements that we want. Okay, so the number of elements that we want to allocate the memory to, so let's call it num equals let's say 8. Okay, so we want to allocate 8 blocks. All right, so after that what we are going to do is that we're going to write here a print statement, printf, and we tell it that we have 8 elements to allocate memory to. Okay, and then what we do is that we can also basically write here we have %d elements to allocate memory to. Okay, so after that what we do, we put /n, which would take the cursor to the next line, and then we have here the variable which is num. Okay, then we come to the next line, and now what we are going to do, that we are going to dynamically allocate the memory using the memory allocation function. So the general syntax of that function is something like this. Okay, so let me just type in here the general syntax and then I'm going to comment it. Okay, so ptr first of all, then you put an equal sign, then basically you have here the cast type. Okay, and steric, and then you basically call the function malloc, and then inside of that you basically pass the byte size as an argument. Okay, so that is the general syntax, okay, of using the memory allocation function. So yeah, we just comment it. Okay, let me just comment it, and then what I'm gonna do, that now I'm actually gonna use it, okay, inside our code. So what I would do, that I would write here ptr equals, and let's say I want to use the integer typecast. So in that case what I would do, I would write here int and then steric, and if you want to use float typecast, then you can write here float, And after that, what I'm going to do, that I'm going to write here MALLOC. I call this function, and inside of that I put in the byte size, which I would say, let's say size of, and then in here I type integer, and then I multiply it with as many number of blocks as I want. Okay, so we have 8 elements, so obviously we want 8 blocks of memory. So I could type in here 8, but as you can see that we have you know, pasted the 8 in the variable num, so we just write here num. Okay, so now what this line would do, it would allocate the memory of integer size, for integers obviously, 8 blocks of the memory. Okay, so I hope you got the point. So now I just put a semicolon here, I come to the next line, and now what I'm gonna do is that I'm gonna check if the memory has been successfully allocated or not. Okay, so we all know that if the pointer is null, then in that case the memory is not allocated. If the pointer is not null, it means that the memory has been allocated. So we write here ptr double equals null, and then we write here, you know, curly braces, and inside of those curly braces we write printf statement, and that printf statement would basically says that memory is not allocated, memory or memory allocation failed, and you put a semicolon here. And obviously if the memory allocation is failed, there is no need to go and execute the rest of the program, you can just come out of it. So for that we have exit. Okay, so we'll put in here exit, we write here 0, put a semicolon here, and we are just done. So now obviously if that thing is gonna be successful, if the pointer is not null, then you want to have here the else block, and inside of else block you can have multiple you know, stuff, whatever you want to, but we would just have one single stuff, one single printf statement, and that would be that memory allocation has been successful. Okay, so yeah, that's it. So once you have done that, now what you have to do is that you have to store, or you have to get the elements that you have typed in. Okay, so let's say we have, you know, number of 8 elements, that is the memory that we have. So what if now, let's say now we want to put in those 8 elements. Okay, so in order to put those 8 elements in these, you know, 8 memory spaces, or in those 8 memory blocks, what we would do would have a for loop. So inside that for loop we would save 8 elements, we would pass 8 elements, which would be saved then in the pointer. Okay, in the memory using pointer, you can say. Okay, so now we'd write here a for loop, and we'll write here for, let me just come here, for, and then I initialize integer I equals, let's say I want to I want to start from 0. Okay, and I put a semicolon, and I would have I less than num, which is a number. Okay, so what it is gonna happen, that the general numbering of starting from 0, it would be saved in those 8 blocks. So in those 8 blocks, what would be saved? 0, 1, 2, 3 till 7. Okay, so these would be the 8 elements that we would store in those 8 blocks. All right, you can store different elements of your choice. For example, if you start from 72,